Hey there! In this lecture, we're going to learn about feature scaling. Feature scaling is one of the pre-processing steps before we feed the data into the machine learning model, and it is considered to be the most crucial one because it will become the deciding factor whether the machine learning model performs well or not during training. So what we need to understand about feature scaling that there are typically two types of methods to perform feature scaling. We can normalize the data and standardize the data. Standardization and normalization are different in a way that when we normalize the data, we are fixing the range of the data between two values. And typically they are between 0, 1 or 1 and -1. In standardization, we transform the data to have 0 mean and the standard deviation of 1. So what it means that we control the spread of the data and we localize it around the center point. So there are many advantages to do that, and the reason I mentioned that it will be the deciding factor between whether the machine learning model performs well or not has a couple of reasons. So why do we need to do scaling? So one of the reasons you need to understand that machine learning model only sees numbers. It does not understand the semantic concept of the features itself just by looking at its names. So given this example, we have this list of different fruits and their prices along with them. So we have two features over here. We have the weight and price. So the machine learning model only sees these numbers. And given that the weight is greater than the price in all the instances, the machine learning model will think that these numbers are superior to the price in a certain way. But that's not the case. But since they have greater value, it will interpret it like they have more superiority and they can be the decisive feature in this model. So the machine learning model gives them more importance considering they have greater values. But that's not entirely the case. The same concept can be applied when we have given the difference between $10 and 10 grams. We all know that it's entirely different given the context, but to a machine learning algorithm, they're the same. So that's the reason we need to make sure that there is no difference between the values, between the ranges of different features. There have to be some type of standard domain, standard range of all the features, and all the values should lie between that range so that it becomes easier to give them equal importance, and there should be no bias based on their magnitude values of the features. So another advantage of doing feature scaling is that it helps the gradient descent to converge faster. So we need to remember that gradient descent is the algorithm where the training and the learning takes place, where the weights of the machine learning model are the most optimal one. So as you can see, we have two different types of figures over here. On the left, we have the gradient descent without scaling. So the values are quite spread out. They form an ellipse, they are elongated, and they are quite spread out. So what happens is it takes a lot of time for the algorithm to converge to the center. There is a lot of deviation, algorithm isolates, there is a lot of oscillations of the algorithm above and down. So it takes a lot of time to converge it to the middle. But on the right, you can see that the figure is forming a circle, or a sphere if you can say, if it is more than one dimension. But it is what I mean to say that it's uniform along all dimensions. So what happens is no matter where you start, given that the gradient descent always starts from a random point, due to random initialization of the weights. So no matter where you start, you will converge to the global optimum faster because there will be lesser oscillations and due to the lesser changes in values of the features. So the next question you should ask yourself, when should you decide to do scaling? So the catching, or you can say the deciding factor for that, is whenever you have to study the machine learning algorithm. So if you're using a machine learning algorithm that calculates the distance of the data, okay, so if we're talking about distance of the data means that, let's suppose you are using an unsupervised machine learning algorithm k-means, and you need to calculate the distance, you need to calculate which of the features are closest together. Or if you're using linear regression, and most of them require the difference of actual and predicted value. So there is the distance between the actual and predicted value, which is considered to be the error in case of a linear regression. So that's what we mean by distance. So whenever we are dealing with such types of algorithms, we need to make sure that the features are scaled. Some of these algorithms in which we should consider that are neural networks, but in neural networks, we do not calculate the distance, rather we are more concerned about the convergence rate, because neural networks are, when we will study in deep learning, we will see that they are huge multi-layer perceptrons stacked together. So it takes a lot of time for the error to backpropagate through each neuron. So it is these algorithms are rather slow. So in order for the speed up the process of convergence, we need scaling in neural networks. KNN, like I said, KNN is used in clustering, and it is concerned with the distance in calculating the distance of the data. So that's why we need to do scaling in that. PCA is another example that is also required scaling. So the algorithms that are rule based, which include the random forest tree or any other algorithm like the naive Bayes, or basically the algorithms that are defined by rules. So we do not need feature scaling in those types of algorithms. Okay, so let's see the types of scaling which we can use to perform the feature scaling. So we have two types of scaling. We have the min-max scaler and the standard scaler. So what the min-max scaler does is that it takes every value and subtracts it with the minimum, and then it divides the maximum and minimum value. So it's actually shrinking the data. As you can see in the figure, we have one example where it is before scaling and the red one shows after scaling. So the data moved towards the, you can say it is moving towards 0. So it is shrinking the data overall. So it shrinks the data and makes sure that all the values lie in the range of 0 and 1. And it makes sure that all the values lie between 1 and -1. So if you have negative values, we can change the range between 0 and 1 as well. So the one thing we need to note, that since it is actually involving minimum and maximum values, so we need to remember whenever that happens, the problem arises with outliers. So because they are either maximum or minimum, mostly the outliers are having extreme values. So that may be one of the roots or the disadvantages of using a min-max scaler, because it is very sensitive towards outliers. The other one we have is the standard scaler. So the standard scaler, what it does, that it considers the distribution to be normal, and then it transforms the data by changing the mean to 0 and the standard deviation to 1. You should think that this is quite similar to the equation of normal distribution as well, when we were talking about normalization of the data when you were talking about the normal distribution. So this is the same equation as well. So standard scaler is the most popular one used in machine learning algorithms, and it is the most popular used and quite repetitively used whenever we are talking about the pre-processing of or scaling the data.